So station number 2 is about negative exponents. So here's the first example. We have 3t to the negative 2. So what I'm going to tell you to do, like I've done already, is I'm going to tell you to put a box around anything that has a negative exponent. So t to the negative 2 has a negative exponent, so we're going to put a box around it. I put an arrow because the law says that if you have a negative exponent, it's going to move down to a denominator. So we would rewrite this as 3 over t squared. With this rule or this law, we're not doing any real evaluating. All we are doing is rewriting. So there's nothing really to figure out. You're just rewriting the expression with positive exponents. All right, here's example number 2. We have 4 variables. 2 of them have negative exponents. So I'm going to do what I told you to do. Put a box around the negative exponents. So you should be doing that yourself. Okay. Then you're going to make sure you remember that negative exponents move down. So they're going to move down. Notice that the a squared and d to the 5th, nothing happens to them. They're staying up at the top. So we have a squared and d to the 5th on the top because they were positive already. They didn't have to move. Nothing happened with them. But the other two, b to the negative 3 and c to the negative 2, are going to move down, and when they move down, they're going to become positive. So this is going to become b to the 3rd and c squared. So the answer to the second one is a squared d to the 5th over b to the 3rd c squared. All right, example number 3. We have 7a b to the negative 2 over 3w. Well, this one already starts off as a fraction, so it's kind of nicer. We don't have to create a fraction. It's already in fraction form. You do what I've said. Put a box around the part that has a negative exponent. The only thing that has a negative exponent in this problem is b to the negative 2. And that b to the negative 2 is going to move down. So we have 7a over 3w b squared, because when it moves down, it becomes positive. Notice that the 7a and the 3w didn't move, or nothing happened to them. They're still, the 7a is still on the top, the 3w is still on the bottom. The only thing that's happened is the b to the negative 2 is moved down. All right, so the try this problem for station number 2 is 6 to the negative 1st, m to the negative 3, n squared, p to the 5th, q to the negative 2. What you're going to do is you're going to work this out with your group and see if you get it right. Hit pause. All right, so the first thing we're going to do is we're going to identify the parts that have negative exponents. So we have 3. 6 to the negative 1 has a negative exponent. M to the negative 3 has a negative exponent. And q to the negative 2 has a negative exponent. Those 3 things are going to move down. So because n squared and p to the 5th, nothing happens to them, they're going to stay up top of on our numerator. Okay. We're going to draw a fraction line. 6 to the 1st moves down. M to the 3rd moves down. And q to the 2nd moves down. Now the only thing that you'll have to do here, and this goes for anything, if ever you have a problem where you have a coefficient raised to an exponent, you need to evaluate that. So 6 to the 1st is easy, it's just 6. So it's not a lot of work. But if you had like 6 squared, then you would write 36. And I'm a little squished, so I hope that you can see. I'll read it to you. The answer should be n squared and p to the 5th over 6 m to the 3rd q to the 2nd. That's a 2, even though it doesn't look like it. It's a little squishy. All right, there you go. That is the try it for station number 2.